Hello everyone. So in the previous session we had started our discussion with functions. So in the functions, as you saw that we have these parameters. So how we write a function is definition, and then we'll write a function name. That will be something like this, function name. And I told you the convention. The convention is that you should use all small cases, and if you have to separate out the word, you should separate out it with underscore, and then you have these parentheses, and in between you have these parameters. Let's suppose a comma b. Okay, and these are called parameters. Once they receive the values, then they're called arguments. Okay, there's a difference between parameters and arguments. And then there is a function body. So this is the body of the function. Okay, okay, then once we have to call this function, we'll use this function name. Same, we'll use function name and then call it with the arguments. Let's suppose 20 and 10. These are the arguments now, and these are the parameters, and these are the arguments. Okay, this is what is called as a function call. Now we have also studied about the parameters. We saw different types of parameters, positional parameters, or maybe positional arguments. Then we saw keyword argument. A lot of arguments we have seen so far. So now what we'll do is, just to wrap up that thing, we'll see basically we have positional arguments, and we can unpack them with star. Okay, so I'll say unpacking positional arguments. You can keep this heading, positional arguments with star. Okay, so what I mean by this is, let's suppose now if you want to add numbers, and those numbers in the list. Okay, you have a list of, let's suppose, 3 numbers, and those numbers now you want to add these numbers. So what you can do is, you can just pass that list as an argument to the whole function, and function has to unpack those things. Okay, better than talk, let's show the code. As there is a quote, talk is cheap, show me the code. I'll show you the code, and let's go to this VS Code. If you can see it here. Okay, let me just define a function. Okay, so I hope the screen is visible. Let's define a function add. Let's suppose define add function. Let's suppose it takes arguments a, b, c. I have 3 numbers, which it adds, and I want to basically see the sum of these numbers. Okay, so what I can do is, I can say print a plus b plus c. Okay, this is what I want to see. Okay, so the one method of doing it is just pass these arguments 1 comma 2 comma 3 like this. Okay, and now I can just run the file, python test1.py. so this is the file name. You can see 6 over here. But what I was showing is, unpacking is that if you now have these numbers in a list, let's suppose, okay, these numbers are in some list. So li is the list name, and I have these numbers 1 comma 2 comma 3. These are the numbers I have in the list. So what I can do is, I don't need to just call li of 0, li of 1, li of 2. I don't need to index this. So what I can do is, I can just call this list like this, li, okay, and then I'll put a star in front of it. So what this will do is, this will unpack this list. Okay, this will unpack the list. So if I now call this, so now you saw that these 3 numbers were in the list. So if they were in the list, I'll have to unpack them somehow. So by unpacking, I mean I'll have to get separately 1, 2, and 3. So one method was just call it li0, li1, and li2, and then pass it to the function. The other method that Python gives us is that you can just use this star. Okay, if you use this star and then call this li, so what it'll do, it'll unpack these things. Okay, it'll give 1 to this a, 2 to this b, and 3 to this c. So now if I run this, I expect the same answer that we got earlier. Okay, so are you clear with this unpacking? Okay, in this example, what we have is, we had this list, and it unpacked into 3 individual arguments, like 1, 2, and 3. And when we call this function add. Okay, so we can do the same thing with tuples. Let's suppose this was list. If we have a tuple or maybe tuple of elements, so like this, and then we want to add them, you have to similarly say, let's suppose we call this tu, you have to add it in the
Excuse me,
similar
sir.
fashion.
We can't see the code
So we
here.
can't see the board, sir. It's not visible, whatever you are writing.
Just give me a sec, give me a sec. So what I was saying is, let's suppose now if we want to unpack, by unpacking I meant that, let's suppose I have a function like this, def add, and it takes argument a comma b comma c. It takes 3 arguments. Okay, then I'll have print a plus b plus c. Okay, so one way of doing this is, I'll say add, and I'll write numbers separately, 1 comma 2 comma 3. This is how I'll write it. So now if I run this, so what I'll get is python test1.py, that's 6. Okay, so now what I'm saying is, let's assume that these numbers are in some they're in some iterable basically, where I can iterate through elements. So let's call that a list. If I have a list li, in which I have these numbers 1 comma 2 comma 3, Okay, now one way to unpack this thing is I can do one thing. I can say li of 0, okay, li of 1, okay, li of 2. This is what I can do. Okay, then I can call this function as it, because now I unpacked manually. Okay, so this is what I did. I unpacked the things manually. So if I now run it, you can see the answer 6. But there is a way to unpack it. So I said there is this operator, star operator. Okay, what I can do is I can just write star of li. Okay, what this basically will do, it will do the same, it will do the unpacking of this. Okay, this is the iterator, it will do the unpacking of this and we'll get the same answer. So if I just run it, you can see the answer 6 appeared on the screen. Is it clear now? Any questions on this?
What if our list contains more than 3 elements?
Yes, then there is a problem, because let's suppose now if we have this 4, good question, and now it will unpack it again, but here as they are positional arguments, so one argument is more now. So you can see there is that error. Takes only 3 positional arguments, but we gave it 4, because when we applied this star li, so what happened? It unpacked the things. Okay, so it unpacked it 1, 2, 3, and 4, and it gave this this as an it basically evaluated to add 1, 2, 3, 4, but it only received 3 it only has 3 arguments but received 4 arguments. And even a question can be if it has 2 arguments only, so then we'll give one less argument. So now if I run it, you can see that missing one required positional argument. Okay, it's a good question that if we give more arguments, then there's also a problem. If we give less argument, then there is also a problem. So we should upfront know that how many parameters that the function receives. That we should know the function signature, and accordingly we should unpack the list. Okay, I hope this is clear. Now you can do this with tuples also. Let's suppose we have a tuple like this, and we have 1, 2, 3, 2, 3. Okay, and then let's call it tu, and the same thing applies here also, tu, and I'll save it. Just run the file, and you can see the 6 as an answer. Okay, so in these things, in these examples, what we did is we had these lists or we had these tuples, or usually in generic case we'll have these iterables. So in that, when we apply the star operator, what will happen is the star will unpack it. So once it unpacks, and after that you will get these as arguments to the function, and function will now operate according to whatever is written in the body. Okay, and now this is the usage of the single star. Now if we have these keyworded arguments, the first thing that we studied was positional argument unpacking. So we can also do keyworded argument unpacking. Okay, let me hide this VS Code for a sec. So the topic that now we have is keyword argument unpacking. Okay, so now you know that we had studied about keyword arguments. So in those keywords we had that, let's suppose we had this definition, and then we have a function, and then we had these parameters a comma b, let's say, and when we call this function, we said a is equal to 1 comma b is equal to, this is what we call as keyworded. Okay, it was stored at dictionary when we saw that. So now let's suppose we have something which stores something like this. We have a dictionary, let's suppose. Okay, and if we have a dictionary and we want to unpack that, so we can unpack that by using this double star operator. So I'll write it here. This double star operator is used to unpack these things, and that's why I have used keyword argument unpacking. Let's go to the code and show it there. Okay, I'll create a new file. I'll write code test2.py. Okay, and new file should appear here. So what I'm saying is, now what we'll do is we'll write a function. Let's suppose define a definition and we'll greet somebody. Okay, and with the first name and the last name, with the first fn and ln. Okay, and then after that, it's really hard to type when you are having pen in the hand. So after that, what you can do is you can say print. Let's suppose now you'll write f string hello. Let's suppose now first name and the last name. Okay, so one way is to just call it. Let's suppose we'll call this function like this. So if we want to greet, the easy way is to just say greet and then say name. Let's suppose Mahmood. Let's suppose Hussein. Okay, now if I run this file, so this is test2.py. This is hello Mahmood Hussain. So now what I'm saying is, now usually you will have these sort of values stored somewhere in the files. Okay. Now usually what we do is when we store these things, we load them in a dictionary. Okay. Because dictionary now have these key value pairs. Okay. So how we'll create a dictionary? Let's suppose we have this. We have person. Person is now a dictionary. So in this dictionary, we'll have the first name fn. Okay. We'll have first name fn, and then its value is, let's suppose fn's value is Mahmood. Okay. Sorry if I misspell the word. Okay. And then the second element of the dictionary is, now again it will have key value pairs. Then we have last name. This is the key. And this corresponding value is, let's suppose, Hussein. Okay. And now what we can do is we can call this person directly. Okay. Consider this as a file. Okay. We're loading file from the database, or maybe we're loading file from some local system. So in that we have these names. So once we retrieve these names, so what you can do is you can store them in a dictionary like this, first name and last name. And then what you can do is you can just call this person, but now you have to call it with double star. Okay, now it shows this double star. Basically it unpacks the dictionary. So that's why I said it's keyworded argument unpacking. So where you have your unpacking keyword argument, it's not just positional arguments. Okay, so now if I save it, I should get the same result. That's now you got hello Mahmood. If we now have person 2, let's suppose, so we have some person, say 2. So in here we have the name is Fahad. Okay, and the second name is Taj, let's suppose. And now what I can do is I can just call person 2 on here. So I'll expect the same output. So you see hello Fahad Taj. Okay, this is unpacking of the keyword arguments by using this double star operator. Now what you can do is you can combine both of these things together. Okay, you can combine these two things together, and where you have let's suppose one unpacking maybe in the tuple and another maybe in dictionary. Let's suppose somebody's, usually what happens in relation databases, let me just give you this. So let's suppose you have this humongous details, and now you have these, you're working in a company. Okay, just focus here for a second, because this will be a real world case study sort of thing. Let's suppose you're working in a company's name is ABC. Now you have a lot of details about your employees, and what is the job role they are, what is the project they are in. So all these details are there. Okay, let me write it. So what I'm saying is you are owning a company, call that company ABC. So in that you have employees. Okay, you have employees, and then for each employee you have a name given to the employee. Okay, you have ID given to an employee, let's the unique number by which you identify that employee. Okay, and after that you have address of the employee, and then you have projects that this employee works on, and then probably the salary of the employee. Okay, and then the relationships with the people. Let's suppose he has other family members, he has some relation dependence on him. So these will be details about the employees. So now if we saw right, let's suppose what happens is, if we have a person working in 2 projects, so unnecessarily we'll write his name. We have to write those 2 things here. So let's suppose Mahmood is working on 2. So we have 2. We have name Mahmood. His address is, let's suppose, XYZ, and he works on project, let's suppose MedAI. Okay, and then his salary is, let's suppose, 500k or something, and then I have some relationships here also defined. Okay, so now if he works on some other projects, or let's call that as finance, he works in that project also. So what you will see is that you will again have this ID2, you will again have this MAH XYZ, then again have this fin, again have this 500k. Basically you are repeating the information. Okay, if he works on multiple projects, you'll have to repeat his information. So this is a huge problem, because you are storing things multiple times. So who is able to see the problem? Is there a problem? Do you see that we are using the we are basically using the things 2-3 times? Are you able to see it? This is just a vague example, but I hope it gets the point through. Okay, so what I'm saying is, now you have this. So what you basically do is you do what's called as normalization. So in that, what you do is you convert these tables. You will say, okay, I'll have a table which has employee, and it just will have ID and it'll have name. Okay, then I'll have project. This is a separate table. It'll have project ID, project name, and project budget or something. So now what I'll do is I'll create a links between each other. So if let's suppose Mahmood is working on this project, he'll be somehow linked to this. So okay, so here we'll somehow link this project to Mahmood. Okay, and then he'll have this project ID and this project ID. So what you can do is, you will, by this normalization process, when you are having this huge database, you split it into multiple tables across. Okay, this is the structure in the relational databases. You split this data into different tables, so that once you require that, let's suppose Mahmood is working on that project, but you are not now storing the project information in the same column as employee. So you will just see, and you will see Mahmood working on this project, then you will directly go to that project and you will see what the details about the project. Okay, if Mahmood is working on some other project, you will not require to replicate the information, you will just refer to that project. Okay, he's working on this project also, so project will have a lot of information again, so you don't need to just have one table, you will have different tables. Okay, and then to remove these redundancies, we use this normalization. So this concept came because I was teaching you. Now if you have why do we require these things? The thing is, you will have to refer to these different tables, you will have to load these different tables into the data, into your data, and then you will have to see how to connect these things. Okay, and this is how basically databases nowadays made. Usually relation databases are the norm right now, that de facto how people use that. They'll make different tables, and then they'll have connections within the tables. These connections are usually called as schema. Okay, they're called as schemas, and if you have any database, you have a schema there. Okay, you'll have to see, okay, this is the primary key of the table, and these tables have primary keys and stuff like that. This is a whole subject itself that you might have studied in database management systems. Okay, so when you are doing this, you have to combine these, you have to combine a lot of things. Okay, now what you can do is, let's suppose you have these two tables. You have tables where you store the name. Okay, and you have other table where you store age in the city. Okay, let's suppose you have a table where you store the name of the people. Okay, and you have this table where you store these names, and then you have the table. What you do there is, you basically store the city. Okay, and with this with something, and maybe something else. So now what you can do is, you can use this positional and keyword argument unpacking together. So you load this thing into some file, and then you will have to unpack. Let's give me a simple example so it gets the point across. So now we are basically combining these positional and keyword argument unpacking. So now you have loaded it somewhere, now you have named that. So what I can do is, I'll just copy some lines of code over here, and then you can see that. I hope you are able to see VS Code. Let's go to the VS Code. So now if I just, this is basically using them in combination. So I have one table, let's call this arguments. Okay, and maybe it's Alice and age is 30, and the other is city and New York. Okay, here we have, this contains name and the age. Okay, Alice is the name and 30 is the age. So this is some of the positional arguments. So these are positional arguments. And then we have these keyword arguments. So here we have city and New York. Okay, so these are our keyword arguments. So maybe they are stored in two different tables, but once we load them, we'll probably load these Alice and 30 will load name and the age in this variable args, and we'll load the city into this New York. Okay, it will be a dictionary again. So now what we can say is, I have defined a function introduction. What it does is, it basically takes the name as an argument, and then age and the city. Okay, now I'll have to unpack this. So now you know that this is a positional argument, and if you see, this is an iterable. So it's iterable and it's a tuple, and I can just get at each element. So what I can do is, I can unpack this by using this positional args. So star arg, so it'll unpack it. So now here you can see it, it's keyworded. Keyword by keyword, I mean it has city, then New York is written. It's a dictionary there. So for that, for unpacking of this, you'll require these keyword arguments and double star. You'll use this double star and then keyword args. And now if I print the introduction, I hope to get the answer. Okay, my name is Alice, I'm 30 years old, and I live in New York. Okay, this is how usually how do we interact with databases. So we have a relation database, you extract different tables, and then you know the connections. So then you have to present this information to somebody, because you will locally first load it, and then you will have probably some dictionaries, and then you'll have these tuples, and you should know about these things, how to present this information beautifully. This is usually what you saw. You just fill a form. When you fill a form, internally it's stored in some database. Okay, then you will have to perform normalization. Okay, there are different types of normalization. There is something called as like NCF, BCNF, and a lot of things are there which basically reduce these redundancies in the data. Okay, after you have that, once you load the data, then you will have to present this information, because you are minimally using having the information stored in the database now. And once you store that by using code, you'll have to show it something. Let's suppose this was stored in two tables, and you wanted to show the introduction of some person. You just need to get the table. You just need to get that Alice age is 30 and city is New York, because these are the things that will vary. This my name will remain constant. My name is Alice, then it will get changed. I am 30 years old. This age will get changed, and I live in city will get changed, and rest will remain same. That's why usually in websites or maybe in your applications there are very less things that change. Okay, more or less the UI remains same, and then it interacts with the database. Okay, I hope this was clear. With a real world example, this was clear. Any questions on this? Now you understood all of this, at least how to unpack these arguments. If you have positional argument, if you have keyword arguments, how to unpack it. Okay, and I showed you the real world example also, how to do it when you are doing some problem. Now, before going ahead, the first thing I wanted to mention is that once you call a function, what goes underneath the hood? Okay, when you call a function in Python, okay, there are a series of steps. Okay, that I would love to study. I'd love to speak about. So we have, when you do this function calling. Okay, the thing is, what happens underneath the hood? What happens? What happens when you call a function? Okay, so what I'm saying is there is a series of steps that happens in Python when you call a function. What does happen? The first thing that happens is, please write these things down. Okay, what happens? The first thing is a function object creation. Okay, that's the first thing. Function object creation. This is what will happen. So why I'm teaching you this? My task here is not to make you memorize these things. Okay, this is again a design choice, because when you call a function in any language, you have to call a function. In every language, most of the languages in the world, there's a function call. Okay, then you will have to see, okay, when I call a function, what should happen? So I'm just giving you a flow. What happens in Python? A high level flow. Okay, then you will have to think, okay, if I make a language sometime soon, let's suppose if I'm a compiler designer, well, I'll have to think about these things. I'll have to make design choices. Okay, if function call happens, what should go underneath? What should happen during the function call? So that's why I'm giving you the flow. What happens underneath the hood when we call a function in Python? Okay, this is not restricted to Python only. Okay, this is just the flow will be of Python. But my point here is to make you think that once you have to build a compiler of your own, you have to make these design choices also. And I'll give you what design choices were made in Python. Okay, when you do a function call, the first thing that happens is function object creation. So what is this? Is basically the function defined is, so what happens is a function object is created. Okay, everything in Python is object. That's why it's called object oriented program. We'll see what an object is. Just for now, you just think that something gets created, which is called an object. Okay, and this object, it includes the code, its default parameters, okay, and the other attributes like function name and the module it is defined in. Okay, so I'll just write these things. So what it has is, it has these parameters. Okay, function name, and then what's the module it's defined in, because in Python we have modules. You define that in some folder. Okay, that we have to define it. Okay, then what happens is, this is the first step. We have this function object creation. We create an object, and the object includes these things, and it also includes function code. That's an important aspect, and much more things. I won't go into detail. If you want to have detail, go to python.org. That they'll have beautifully written it. I'll just give you the high level overview, just to make you think. If you have to make a design choice, what will you do that time? That's the first thing, function object creation. The second thing is, you have to now call the function. So now that step we'll call it function call. Okay, so what the function call is? So when function is called, Python has to prepare the execution of the function, because it has to perform these things. Okay, so now it will prepare that function call. So what will it do is, because now there are arguments. First, as I said, we had the evaluation argument. It'll see what type of argument it is. Okay, during the function call, it'll see argument passing. It will see those arguments, because we have studied about different types of arguments. Okay, let's suppose if there are positional arguments, what to do with them. If there are keyword arguments, what to do with them. If there are default values, what to do with them. If I have to unpack, what to do with that. Okay, all of these are choices now, because if you give features to users, we'll have to think about these. Okay, how to evaluate these features now, because now I said in Python we have these positional arguments, we have these keyword arguments, we have these default values, and we can unpack. And now we'll have to show them the implementation, show how to deal with that once I do the function calling. So without even letting the user bother about these things. Okay, what is going underneath? Maybe sometimes, let's suppose you are inventing a language. There you don't give keyword arguments. It's all right. There maybe you don't give default values. Okay, then you don't have to deal with these things. All of these things depend on the design choices. You make some design choices, and you will have to see, okay, now this is what I want to keep in my language. And now the thing is how to implement it. So in the argument passing, I said the first thing that happens is function object gets created. It has its parameters. It has this function name. It has the module name. It has its code also. Then this function is basically prepared for the function call. Before that, we have to now have this argument passing step. In this position, if let's suppose we have, I'll write positional arguments PS or PA. So positional arguments, what they do is these provide arguments are matched to the function parameters. So as you know that if the positional arguments are ABC, if we have 3 arguments, now if we give 1, 2, 3, 4 in the function call, then you should match that something is extra that we saw. Okay, if it is that positional argument, so it will do this checking. If there are less arguments, if there are more arguments, are they in order or something like that, it will have to check for that. Then we have these keyword arguments. We have keyword arguments. So for that, the provided keyword arguments are matched to the function parameters. So, okay, if let's suppose we had parameter a, b, a, comma, b, comma, c, and we write something, a is equal to 1, b is equal to 2, and then we wrote d is equal to 3. Now d is not in these parameters. Okay, now you'll have to do that checking also. So for the positional argument, it had to do one set of checking, and for the keyword argument, it has to do other set of checking. Then for the default arguments, now if we have default argument, it has to check was the argument given. If it was given, then override the value, and we have seen what it does. It sometimes overrides, sometimes does not. It depends on the mutable and unmutable objects. Okay, and if it is not given, then we have to use the default value. And then if it is unpacking, so we have to unpack these things also. Okay, so during argument passing stage, so what happens, all these steps are taken care of. So now we have to see what type of arguments are there. So if these are the types of arguments, so accordingly we'll do that. And then what we do is, that's called as the one more step. Once we are done with this, once we evaluate these arguments, that's what I said before the function evaluation, argument evaluation happened. Okay, once that is done, once we are convinced, one Python interpreter is convinced that these are the arguments that I'll take, so though it goes forward, then what it does is it will create what's called as stack frame creation. You don't need to memorize them. Even I don't memorize them. I have written it somewhere. I'm just reading it from there. But I just want to tell you the flow, high level flow, what's going underneath. Why is it important? Again, reiterating that thing, because these are the design choices the designers made, and now they'll have to give the implement details. Okay, how to implement them effectively. Okay, now we have this function object creation, we have the function call, and we have this argument passing. Now what we do is we have this stake frame creation. So in that, what we do is we basically create a new stake frame. That's called as execution context. This is also called as execution context. Okay, once you do that, so this this basically is a memory. Okay, this is stake frame. It includes local variables, and we'll see what these local variables are. Okay, it includes local variables. It includes the other parameter details and the state information, and a lot more. I'm just giving you some things that it stores. Okay, after this, now this stack is pushed. So this is a stack. This is called as execution context. Now if you know that once you call a function, okay, in the program there might be multiple functions. A function may call other function, and there may be different calls. So we have a function stack also, a working stack. Okay, let's suppose we have the main program. Okay, main program calls some function, and now once this stake frame got created, then we'll basically push it on the stack. That's what the first step is, that you create this stack first. You create the state stack. You create this frame, which is called as execution context, with these local variables, state information, and other things. And then you will have to push this onto the stack. Okay, this is the function calling stack. So there are two different types of stacks working here. Function stack. So function calling stack is the stack where we keep the track of which calls happened. So let's say we first called main. So main will be pushed first, and then we call some other function. Okay, then we call some other function. Okay, this is basically that's what's keeping track of. So what do we push in that stack is this context execution. Okay, the first step in this is that we create a new frame called the execution frame, which contains this information that I have written here. And the second thing is that you have this stake frame. Now you push this onto the call stack. Okay, this is called as call stack. Like this keeps the track of the function calls. And then what you do is you now do variable binding. After that, you do variable binding. So you have these values, now you have these variables, you have to bind the values to each other. Let's suppose in the function you had these parameters, then you have the arguments. Now you have to do these bindings, and you have these local variables which are probably initialized. You have to initialize them. Okay, and after that you execute the body. You execute the body step by step as you have the usual code, and at the end if you have the return statement. Okay, if nothing is returned, then none is returned. So if you don't return anything, none is returned. And then at the end you do cleanup. So what I mean by cleanup is that once that function call is done and you return the value to the caller who had called it, you have to do a lot of these things. You have to free, let's suppose, some resources, okay, and maybe you have opened some files by using the function call. You have to close these files, and a lot of cleanup has to be done. Okay, so what are the usual steps? The first step is that you create a function object, okay, and a lot of things happen in that, and then you call that function. During the call, what you do is you have this argument passing stage, because you have to pass the argument, because now before the function body gets executed, we should take care of these parameters, how to evaluate these. Once we are done with this, then we create a stack frame creation, and that we call it an execution context, and that is pushed onto the calling stack. We have a calling stack of the functions, and after we push it onto that, then we have this variable binding. We have these parameters which were given, and then we have these local variables, and we basically initialize these local variables, bound these parameters towards the arguments, and then execute the main body of the function. At the end, we return. If nothing is being returned, then we return the none, and then at the end we return we clean up this. So this is what is going underneath the function call. It looks just a simple call, but this is what a compiler designed, or maybe interpreter designed, or a program inventor, maybe the guy who is writing the language, he'll have to take care of this. Okay, this is just one way of doing it. There may be multiple ways, and it depends on what are the functionalities that you give in the programming language. Okay, it depends on that. If you want more functionality, you will have to again make the design choices, what to do. Okay, should I do something else? Okay, and it depends on those things. And who makes design choice? The designer. So whoever designs this, and he has to make these design choices. I hope that I got the point through. The whole point of telling you this is that you have to be in the foot of the designer. Okay, once you start thinking about how the designer would have thought about it, it's not just a language. Okay, it was created by somebody. He was a human. Okay, he had thought of something. So when he gave that, so this is what he had to deal with. Am I clear with this? Any questions? I'll pause here for maybe a couple of seconds to take these questions. So for this, if you're more interested in learning more of these things, do ask me once. I'll provide the resources where you can read in much more detail what happens underneath in the Python. But it was just a primer for this thing. If you have to make a programming language of your own, how to think like a designer. Okay, because I have promised you one thing, that probably I won't teach you much of the programming. That will anyway do. That's a collateral, or maybe that's just a byproduct. The more and more things that we'll learn is how to think, how to be in that designer's shoes. Okay, now I want to think from a designer's perspective. What are the design choices that he had to make? Yeah, okay, and now we'll move on to the next topic. So next topic will be, so when we call these functions, okay, function calling, and then you give these as in the previous session we got some question about call by value and call by reference. Okay, this is the question that we got. Python deals it with a variety of its own. It deals it slightly differently. So now, but still, I'd like to cover this topic of call by value and call by reference anyways. So what it does is, basically when you now call a function, so you have to call a function and you give it some arguments, and after that what happens? Okay, that we'll see. So what I'm saying is, there are two ways to do that. So in generic programming, there are two ways. Either you call by value or you call by reference. That's what usually people do. If you are from C++ background, that's what you know about these two things. So there, if you are passing an argument, you can pass it by value or you can pass it by the reference. Okay, what I mean by that is, okay, let's see what is called by value. So first we'll deal with what is called by value. So call by value is, let's suppose you just give the value. Let's suppose you have this a is equal 10. Okay, now what you do is, so if you have this definition of some function, VS Code is not visible, right? So you have a function and you take some parameter, let's suppose a, and once you call this function, you call it with some variable. Let's call this variable x, so that it becomes de-anonymized. This is x is equal to 10, and you call this x. So if this thing happens, that this copy does not have an effect, okay, so this a basically is a separate variable from this x. Okay, when you call something, so call a value is that you give this value, so whatever value it has, it basically gets copied into this. Okay, this a now got the value 10, and whatever happens to this copy, it does not affect this, it does not affect your value. Okay, so this is what is called as call by value. Just give the value, you don't give the reference to this variable. Okay, and whatever changes are made, these changes are made locally in the function, and once that function is done with this computation, and you saw that we have the stack of function calling stack, or we call that call stack. So once it is removed from that stack, so all this information is gone. Okay, and then we are left with this information. So call by value essentially is that you just give the value to the function. Okay, and that value gets copied into its maybe local variables, or its parameters, whatever it gets copied into, and it does a computation, and it does not affect your original copy. That's what call by value does. What is call by reference? Call by reference is rather you'll give a reference to this. So you have this now. If you have this function, if you call this function, and then you call it with a, and usually in C probably you call it with star a or something. So what you do is, so there you give the reference of a, because this let's suppose x is equal to 10. This is stored somewhere. Okay, let's call this x, and you have this star of x over here. Okay, or maybe usually you say ampersand of x. So you give the address of this x. Address of x basically means you're giving a reference of x. So whatever change now that function makes, because this function is defined somewhere. This function is defined somewhere with some things. Okay, whatever change it does, it makes, whatever computations it makes, okay, that change will directly appear here, because you are giving the reference, not the value just. Okay, that's what they're called as call by value and call by reference. Call by value is when you call a function and you just give the value. That value is basically bound to different variables, and if you make the change, it does not affect the original variable. But call by reference is when you give the reference the variable. When you give the reference the variable, and when you give the reference, if the changes are made by the function now, if function does any change, that will be visible in this. So this is called as call by reference. So these are the two things that usually programmers use. So they either use call by value or call by reference. But what happens is, so Python basically uses something different. So I think we just touched it in the previous session also a bit. So I'll show you what Python does. So Python handles it differently. Okay, so Python handles it differently because we have in Python we have these mutable and immutable objects. Okay, so first we should have an understanding of how mutable are passed and why is it crucial. Okay, by mutable I mean you can change. So mutable objects are these objects which can, why you can change, you can have the original reference and you can change the values. And then we have these immutable objects. Immutable objects. I think we also had a discussion on these things. So let's suppose in immutable objects it will be like a number, string. So we have numbers. Numbers are immutable. So immutable will be numbers, maybe strings, and you have a list or data types that are maybe tuples also. So mutable or let's suppose lists, and so on. And when the list, dictionary, sets, and if you are user defined objects you have, and these will be mutable objects. Now these immutable and mutable objects are being passed. Okay. So what will happen now if you pass immutable objects? Let's start with that first. If you pass the immutable objects, let's suppose you have this. We will define a function and we'll pass. Let me write the code directly, rather than showing it on these pen and paper. I'll show it in the code. Okay, let's create a new file. Call it code test3.py. Oh, let's create test3.py. Now it's created, and then what I'll do is I'll make a function. Let's call that increment. Definition increment, and it'll take x, so it increments the value. Okay, what it does is x is equal to plus is equal to 1, so I'll just increment it. Okay, and then what I'll do is I'll print inside the function x, the value of x is this, print app string inside the function, because this is inside the function and I have to say what is the value of x, and the value of x is this x. Okay, this is what I'm doing. So now you know that. Now what I'll do is I'll create an object. This is an integer object and I'll give it value 10, a is equal to 10. Then I'll call this function increment of a, increment of a. So I call this function. Okay, and now I'll print outside the function. So now I'll see print f outside the function, outside the function, and the value here is, I'll say a, that is a. Okay, now you can see that this a basically is over here and this is passed on to this. Okay, so now as you know that this is an immutable object. Okay, if I now call this, so I should hopefully get the value, because now what I have done is this is the immutable. You cannot mutate it. Okay, what will it do is it should give me the result inside the function. It will be 10. Okay, so here if you see, so inside the function the first thing is it should increment it. It should give me 11 for this x, but this 10 should remain as it is, because now what it does, it will make a copy. Okay, so let's now run this code. So test, this is Python test.3. So you can see inside the function x is 10 and outside the function this a is 10. So what happens? Let's see that first. Okay, so now I hope that this is also visible. So if you see this was my variable over here, and you know that this is an immutable object. You cannot mutate it. So once you call this increment, once you call this increment of a now, okay, what happened? This x got the value x is equal to 10. Okay, now you started performing computation on this x. Okay, okay, you start performing computation on this x. So what it does is, so this x plus 1 is now made 11. Okay, and once you make it 11, it had to make a new copy. This x was now different. Okay, now this even if you have named it as a also, okay, if you do not keep it, if you name the variable the same also, so what will happen now, this x only belongs to this function. Okay, because this is a mutable object. Okay, now you can see that this behavior looks something like call by value. It looks like value has been passed. Okay, because it was immutable. There is a concept in Python, there are a lot of animal names. There's a concept called cow. Cow basically means copy on write. Okay, copy on write means when you write something, then only make a copy. Okay, otherwise don't. It's a big concept. We'll take it somewhere sometime else. But here, so what happens if you see this is an immutable object when you gave it to this function. So initially this x was equal to 10, but once you increment this one, so what it does, it made a new object x which belonged to this function increment, and it made its value is 11, and the original value was kept intact, and nothing was done to that value. Okay, this is like call by value. If you just, if it's like when you're calling it by value. Is it clear? Is it clear? Any questions? Any questions on this? To demonstrate this, let's take another example. We'll take immutable object, and that immutable object is string. Okay, we'll take one more example so as to make it more clearer. So what we'll do is we'll say we have a string, and then we'll make a function. Let's call that append or something. We'll call a function definition. A function will be called append. Append, let's suppose string. Append str. So what we'll do is, so in this append str, so we'll take an argument, a string. A string is an argument called s, and then what we'll do is we'll append some letters onto this. Okay, let's suppose if somebody gives me hello, I'll say hello world. If somebody gives me something, so I'll just append, let's suppose, some world into that. S plus equal I'll append world. Okay, this is how append is done, because plus is used for the appending. So what I can do is now I can print it. I can say print, then I'll use again that app string. So I can say again inside the function, outside the function, inside the function, inside the function. Okay, so what is inside the function? S is, so I'll say s, then I'll call this s. This is inside the function. Once I call it, okay, let me now define a string. I'll define, let's suppose I have a text, I have some say text which is hello. Okay, so now this text, I'll pass this value again. I'll now call this append str with this hello. So now I'll call this just text. Okay, now what I'll do is I'll write print what is out, so what will happen to the outside the function. So I'll say outside the function. Okay, now this is basically text. Okay, I want to see if it changed or not. Again, we are in the immutable objects. So here, if you see that, what should happen ideally is, so what have we learned so far? So in that, I said if the object is immutable, as is here in the case. The case is that it's immutable. Okay, this hello, it can't be mutated. So now what is it doing is, it is going here, and this s is now bound with hello. So there is a string hello, and now this s is appended with world. Okay, so what I do is, so I should append it with the world. So I'll write world over here. Let me write it with red. So world is like this. Okay, so it's appended, and now this s has this value. So okay, whatever we learned so far, then this should remain intact. This text should not have been changed, because it's an immutable object, and when you mutate it, a new object got created. Okay, so inside the function it should be hello world, but outside the function it should still be hello. Okay, let's run this to just ascertain our claim. So our claim is that inside the function it should be hello world, and outside the function it should be just hello. Let's see that. Okay, inside the function it's hello world, and outside the function it's hello. So that's the behavior that when you pass it, when you pass it the immutable object, that's what it does. So it basically is like call by value. Is it clear? So I said call by value is a different concept, call by reference is a different concept. But once Python has to implement it, again design have to make design choices. What to do? Okay, they made design choice, because now we have objects. Objects are mutable, they are immutable. Okay, now let's deal with the mutable objects differently. Let's deal it with immutable objects differently. Okay, now before coming to any questions, I'll first show what happens when you pass these mutable objects. Okay, so the heading now is passing mutable objects. If the objects are now mutable, if you have a function call and you make this mutable object and you have this mutable object and you pass them to the function, let's see that was a behavior. Okay, and now we'll again go to the VS Code and we'll create a, we'll save this and we'll create a new test.test4.py. Okay, and then we'll see what happens with the mutable objects. So one mutable object is list. Okay, we'll do it with the lists. I think we have done it in the previous class also. We'll just do it. Define, and we'll say add element or something, add element, and we'll get an input as list. Okay, once we got this list, and then we'll say list append. Okay, we'll append it with some element. So lst dot append, because list on list we can have a function append, and we'll append, let's suppose, some value 4. If we append this some value 4, so then we'll again say print inside the function and print outside the function. Print f inside the function. Okay, and then we have this list. I'll call it lst. Okay, now here I'll create a list. Okay, let's suppose I'll create a list in here which contains some elements. I should give some elements to it. So let's suppose I'll have this numbers, maybe 1 2 3. So numbers is a list. Oh, sorry. So numbers is a list which contains some elements, say 2 3 and 5. Okay, and now what I'll do is I'll call this add element function on this numbers. This number is a list. Now you know list is mutable. Okay, and then I'll have to say outside the function, I'll call this, okay, this is outside the function list, and we don't have list, we have this num now. That's what it is. Okay, so now again, if it is mutable, so what will happen is, so in mutable objects it will be appearing as if we do call by reference. Okay, so what will happen basically is the my argument is like this. So this number, it is referred as the, so list, basically we have this 1 2 2 3 and 4. Okay, and once we have this 2 3 4, and then it is bound to this num. Okay, when you have this function call, when you make this function called l element, and then now this lst is again refer to this. Now this is an object 2 3 4, basically is a list, and it is again, it is bound to this num, it is bound to this lst also. Now lst dot append, now it's mutable. You can see that it's mutable, it won't write the object. So what it'll do is, it won't override it, it'll just append. So we have 2 3 5, sorry, we have 2 3 5 over here, and what will happen here is, so 2 3 5 and then append of 4 should get appended over here. So now you see this num was pointing to this, and list is also pointing to this, and list made change in it, so change should appear for the num also. So num and list is basically pointing towards the same list, towards this 2 3 and 5. So append, the 4 was appended, and once we append that, that should be visible. So what should be the answer? So inside the function we should get 2 3 5 and 4. So outside the function, because now the chains are visible. Why? Because it modified the original list. Okay, then outside the function it should be also 2 3 5 4. Let's see that, and let's run. Let's see if it is like that. We are writing Python test.4 test4.py. You can see inside the function 2 3 5 4, and outside the function the list is 2 3 5 4. Okay, so the first that we have, like we had these immutable objects, in that it looked that as we are passing by value. And now if we have immutable objects, it looks as we are passing by reference. Is it clear? We can do same with the dictionary. We can do same with the dictionaries, because they're also immutable, they're also mutable, and they'll also show the same behavior. Okay, and we can modify this. How can we now modify the behavior if we don't want to do this? Okay, sometimes it becomes a big problem, because sometimes you pass something and you expect it won't change this, it won't change, but it does change. So for that you have to make use of what's called as copies. There are deep copies and shallow copies. Okay, in order to prevent this behavior, because sometimes you want a certain behavior, you are thinking that this should be passed by value. Okay, this should not be passed by reference, because you have a list and you give it to some function and it performs something on that list, and your original list gets modified, but you don't want that. So if you don't want that, you should make deep or shallow copies in order to do that. Okay, or you should make a copy of the, by deep copy we'll have a separate discussion on what these copies mean. So for now you have to make a copy of that list, and then whatever tinkering you make with the original thing, it should not appear there, it should be happening with that copy. Okay, if you have to sort of get the behavior where you don't want to mutate the original, where you don't want to do anything with the original list. So all in all, what I'm saying is, in mutable objects, in immutable objects, it looks like as if it's a call by value, okay, and in mutable objects, it looks as if it's a call by reference, okay, because it gets changed. Is it clear so far? So here again, I'll pause for a couple of seconds to take your question. So here we'll stop today's recording.